that first. What I want you to do is our very first thing, number one over here, is you are going to look at this page of shapes. And you are going to guess, random guess, what you think the average area of any shape on this page is. So take a little bit to look at the page. You're not calculating anything right now. You're just saying, I think. We're guessing, making a blind guess. You can do it however you want, but you're trying to guess the average. Trying to guess the average area of squares. Yes, dear. So, see how we have a whole bunch of shapes made up of a whole bunch of different squares? We're going to try and guess what we think the average number of squares is. So if it was Legos, what is the average number of bricks I would need? So we're guessing. There's no math involved on this one. Yet. Naturally. I'm going to mark our attendance while you guys are guessing. Alright, we got Celeste. Let's see, we're going to go awesome sauce. Yes, dear. Yes, dear. Don't go far. Purple's finally dying. Is this one out of ink or is it just got a bubble? Oh, that is out of ink. That sucker's dead. Okay. Purple pen. Salute your service. Alright. So I want you to write whatever you guess your average to be on the blank next to number 1 on page 101. So 1. Blank. You are going to write your blind guess. So for question number 2, and it's got this little table. What you're going to do is you are going to pick your choice, what you think a good random sample would be. You're going to try and pick, all right, maybe I'm going to use shape number 65 and maybe 19. And you're going to pick 5 shapes and find their average. So if we're looking at this table, it says rectangle number on the top. Maybe I use rectangle number 1, which has an area of 1. Maybe I use rectangle number 10, which has an area of 1. Maybe I use rectangle number 48. It has an area of 6. Okay, so we're writing it like that. And then you're going to take your number of areas that you have and you're going to find the average. Don't use those ones. But you're just going to write it down like that. Okay? So I want you to choose what you think is a representative sample. And you're going to find the average area of those 5. We are going to compile all of our data. So make sure you write it down. And we will use the dice in a minute. I'll walk you through how to do it. We are picking what we think is a random sample from here and finding the average of that random sample we picked. So like you're gonna pick maybe 8, 50, whatever numbers you want. And we are going to wind up compiling our data together, and I'm going to put it together in a code app. So make sure you're writing stuff down, because I'm going to come around and like write what you guys have written down, so I can put it in code app. Because we're going to look at that today and see why we care. Okay, so now that we've picked a random sample and we can hopefully find the average of that, how do we find the average of this sample of 5? How do we find our average of these areas? Add them all up and divide by how many? And in this case, we have 5. So you're going to add up all your areas and divide by 5. That gives you your average. There's a little blank underneath the number 2 set of boxes. That's where you're going to put your average.
How do you find the areas?
So you're going to count the squares.
Oh.
Count the squares. Yeah. Just think of it as how many Lego bricks would it take to build that shape? Those are Legos. Okay, so the next one we're going to do, and this is going to be the first one where we're going to use the dice. We're going to use the dice twice. For number 3, again on the same kind of table, you are going to roll your 2 dice. They are both 10-sided dice. And whatever number you get, so for example, I got a 5 and a 9, so I'm going to use rectangle 59. And then I'm going to roll again, and I got a 3 and a 9, so I'm going to use rectangle 39. So it's giving you the number. Then we'll go back on to page 100 and get the area of those specific rectangles. And you're going to take a sample of 5. That's number 3. Okay, so do that. It's going to be easiest if you have your book open like this so that you can see your table and your rectangle page at the same time. That's going to be your random number generator. It's way easier, way more fun than going on to Google and having it tell you a random number between 0 and 100. So you're going to roll the dice, roll both of them. And we get a 1 and a 3, so that's 13. So you've been randomly selected to have that one. So you're going to put 13 here and the area of the rectangle right there. Okay? What's that? Oh, sorry, y'all. I got distracted. here and you can find. Yep. Yep. Yes. Yes. Totally fine. Thus the benefit of the randomness of the random number generator. And this is the most fun random number generator, because otherwise you have to go on Google and it's just like
Make back happy math for us.
Yes, dear. So we're going to add up the areas that we have, and we're going to divide by how many we have. So we're going to 5, 12, 12, add those together, divide by 5. Okay? And then do the over. And then what you're going to do is you are going to do the same thing, but it's a bigger sample. So number 4 is a sample of 10. So it's the same thing. You're going to roll and randomly select, and you're finding your average. So you're filling in the whole page. Work with it open, because I'm going to come and collect some of your guys' data.
Then we would divide by 10.
And that one you would divide by 10 on our average. You're exactly right. Okay, so you guys do that. I'm going to write down some of your data while we're going, just so I can start getting stuff put in CodeApp. All right. Sweet. I'm just going to take the 1 and 2 right now. Ooh, wrong pen. There we go.
Hello.
Hi, hi. Thank you so much.
You're welcome.
All right. All right, so here we have our information about our guests and our chosen 5. Because what we're trying to do is we're trying to find the average area on this page. And I put our mean and our median up. So we've got, on our blind guess, we have a mean of 31. And on our, we picked 5 that we thought was representative, we have a mean of 12. On both of them, we have medians in the 10 to 16. So they're getting more accurate. So our blind guess was really spread apart. Our chosen 5's coming together. Let's see what happens when we start working in that random 5. So find your area. Please put the page out so I can actually see your numbers. And then I'm going to come around and I'm going to write it down so that I can put those into our data set. And we can see what's happening here. And then we'll look at how the scientists do it and take these kind of big samples. Because what we're doing is each of you is taking a sample. But what I'm going to do is I'm going to compile all of our samples into one data set so we can see what's going on. Okay. It's the same thing with a bigger sample. Keep going. Fill in both tables and find your average. Almost there. You've done a little hard work. Just type it back now. So, I'm going to start putting some of these in. So if you look at the next page, it's have these little space for graphs where you can start putting things in and you're going to like draw your own little estimate of our graph. So we're going to go with our random 5. And we got 4.8. And this one is our random 10. Median labels. Mean, median, labels. There we go. And minimize that. All right. So this was our blind guess. This was our we picked it. Here's our random 10 and our random 5. So all of our data is getting closer and closer together. So on this one, we can start to see if we include our standard deviation on these, we're going to watch our standard deviation get closer and closer together, I bet. Ooh, actually our random 5 was a very good sample. Because what we're trying to do is we're trying to find the actual average of the rectangles here. So we only have, what, 12 samples up there? What would make this be more accurate? How could I get a better true average of the page? How could I get better data here? Because we still have a fair amount of variance here. We have averages as high as 14, as low as 4, as high as 14, as low as 4. We've got a lot of variation going on here. If I don't want to have to add up every single rectangle on this page, and we want to take samples, I mean, we could all go do that again. We could all go do that again, and then again. And we can take more samples. The more samples we take, the more accurate our mean is going to be, our median would be. Because what we're looking at here is we're looking at the average of our samples, not just the average of each box, the average of our samples. And there's ways that they can actually do that for us in software, and that's going to be something that happens when they pull random samples out of big groups. They'll use something like software to do that, and it looks super duper crazy on here. But I'm going to actually spin this case, or start it, and what it's doing is it's pulling samples and finding our averages here. Can you start and not stop again, please? So it's pulling samples. Come on. Oh, it's because it's only selecting 5 at a time. So it's doing 5 samples and it's collecting it 3 times. So it's pulling all of these samples. So it's giving us data here. And it's looking really crazy. These are the samples they're pulling. This is the individual persons. So this would be, this maybe is Jason's. And this maybe is Celeste's. And this maybe is Makai's. And they're pulling just like it was people here. But they're giving us, if we go a little farther down, I think they at one point had the full graph. Where'd the whole graph go? Okay, but we can pull up the full areas of it if it would actually take all the data. Oh my gosh. So let me see if I can get that graph for us real fast. I gotta get it over here where I can actually see what I'm doing. There it is. All right, I think I found it. There we go. There we go. Sorry, new software, figuring it out. And make it back to be big size. So I've got this set up so it should be as I collect more samples, they're going to pop into that graph and they're going to update where are averages? As it's pulling more and more samples, more and more people participating, more and more samples getting pulled, it's getting a closer and closer and closer average to what the true average on the page is. And I can take lots and lots and lots of samples, and it's going to get closer and closer and closer. And so what I'm going to do is, instead of having it collect 3 samples, I'm going to have it collect 100 samples real fast. And it's just going to go, brrr, and we can watch our graph start to fill in. The more samples we take, the more accurate our data becomes. The more samples we take, the more people that pop into that middle, the more people that get an average around 7.54. The closer it is to the true average on the page, the more answers we get in there. So the more people that we have participate, the closer our average is going to be to what the true average of the page is. So when we're taking samples, it's not always about taking a bigger sample. Yes, a bigger sample is more accurate. This was doing 5 samples at a time. We could do this again, and instead of collecting 5 items, we could collect 10. Let me do that real quick. So if we do the same thing, but this time I collect 10, I'm going to grab that graph real quick. So that's this one. So I'm going to pull a sample of 10. And I'm going to hide those words so we can actually see what happens on the graph. So it's going to just pull 3, and it's just going to pull a little bit at a time, and we can start to see what happens. It's filling in those kind of middle spaces. And if I want to see what happens when there's a lot, we can see right here what's happening. It's getting closer and closer and closer to that mean. I can do that again. Pull another 100 samples. And the difference between these, this one I've pulled like 1,000 samples. This one I've only done 2. Already my standard deviation is significantly smaller. This one has a 1.6 standard deviation. I know it's super tiny because you guys didn't sit in the back. And this one is a 2.2 standard deviation. So picking a bigger group, a bigger data set, will give you less variation in what our answers are. So using more than one sample is a good way to collect data. That's what this is trying to get us to notice, is that when we take samples, we cannot just assume that our first sample is super awesome. Because what if I had picked as my super random sample 1, 9, 50, 64, 21, and 8? I would have an average area of 1. That's not super representative. But it could have been random. Random could pull that. And I bet if we look over here on this one, our lowest one that we got was a mean area of 26. I could look at their data, or 2.6. They had rectangles 16, 4, 8. It's like their data's right there. And we could see it specifically. 60, 36, 47, 27, 23. Oh no, that's too high. 32, 6, 4, 8, and 16. So they had a good number of individuals. We can pull up each individual case if we want to. So that's one of the great things. This guy's kind of an outlier too. This one over here way at the 16. This guy, he's gotten a lot of really high values and really does not want to be clicked on. There we go. They got 15.6 as their average area. So we can get all kinds of information, but when taking a sample, which is a fine way to do it, we cannot always assume that our sample is right on the money. So So we take more than one sample. And when you're doing science and when you're doing statistics, you got to pull more than one sample if you're not looking at a whole data set. Because, yeah, we probably could go through and average it. There's only 100 things here. But if we're looking at the world history of hurricanes and we don't have it digital, sometimes the sample's good. If we're looking at, we're going to do something with the length of songs. We don't want to have to take the length of every single song ever made ever. We're going to pull samples. Okay? So samples are super duper important and helpful. There are 3 graphs on your next page. If you want to put sketches of those pictures of what they look like, you can. That's what it's intending to do here. These symbols we're not going to see again. They mean things you know. It's the number of things in the sample, the average, and the standard deviation. We're not going to see them again, but if you're curious, that's what they stand for. Okay? So we're going to be able to compare these graphs together. What we're looking at is how does our data compare to the rest of it. And what we're going to do tomorrow is we're going to look at page 103 and compare someone else's data and the assumptions they made about their data based on the answer that they got. Okay? So that is going to be all we do today. Tomorrow we'll do 103, I think through 105. And we're getting really close to the end of this chapter. Really close to the end of this chapter. Next week is going to be our project week. And we're going to have a whole week to work on the project in class. Okay? So I'm going to come around with my Dragon Scale bag to get my dice. Click, clack, happy math rocks, give back.